Alrighty, number of islands. Let us start. Given an m by n 2D binary grid, which represents a map of ones land and zeros water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontal or vertically. I'm just like copying and pasting the question in here. Yeah, surrounded by water is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay? Horizontally or vertically. Okay. So, first of all, imagine we were like told, hey, make a class called solution, and num_island, like function, like the method inside of it should be num_islands. It should have a grid, be an array of strings, and returns an integer. Okay? So imagine we're given that information. And class is solution. Basically, I'm just trying to get into the practice of writing out the class and this right here. num_islands. Self. Grid. List string. And returns an integer. Perfect. Okay. As long as I know I don't forget the syntax for this. Like again, I don't want to be wasting time on small things like this during an actual test. And then just in case, let's copy this. Class solution, num_island, self, grid, list string, and yep, cool. All right. So now we have this part here. We know the problem ahead. We got to start off with an example, right? Let's assume we don't have the examples given over there in the LeetCode question. What I'll do is we have a list of, so we're given a list containing lists of strings, and those strings are either 1 or 0. So just do it like 1, 1, 1, and then 0, 0. Let me just copy paste that, and I'll just change it up a bit, like maybe this says 0. Change this up like this. Okay, 0, and change this to just be zeros all across. And basically what I'm going for now, just a one at the end. What I'm going for right now is, so you see here, horizontally there's a vertical and then another horizontal. So this like kind of section here with all the ones, this is one island because you can kind of go horizontally and vertically to kind of map that all out. But then this one over here, this is a separate island because you can't go diagonal and there's no like horizontal or vertical way to get to this point. So that's the second island. So if you take a look at this example, right, the output be 2. Pretty sure. Any edge cases to consider? Good question. So m and, well, I guess these are clarifying questions as well. What is the limit of m and n? Can they be 0? I'm assuming they can't be negative. That doesn't make sense, but you know, good to confirm. And given an m and n binary grid, I'm assuming these are integers as well then. But good to clarify. Yeah, so that represents 1s and 0s. So this list, the string can only contain 1s and 0s, but confirm that too. Return the number of islands. Yeah, those are the questions I would clear up. Edge cases would just be like this, like 0 case, like what's the minimum it can be, 1s and yeah, like is there any memory considerations that we need to do? Like how high can it be? And what's the ideal time complexity and space complexity we want for this question? Should I just go for a naive and then kind of communicate with an interviewer as we go? Like, what's the conversation going to look like? Those would be questions I'd ask from the interviewer. So m is equal to the grid dot length, makes sense, and then n would be equal to grid I dot length, like I being like one of the many substring, like one of these in like any of these. And so n, so this is m is gonna be 4 in this case, and n is gonna be 5. So it has to be 1 for both m and n, and it can be up to 300, and only 0 and 1s. Perfect. Yeah. So edge cases, when it's 1 for both. Not really an edge case, to be honest. Yeah, not much edge case consideration. All right, now the brainstorming phase. So we have this one example. And if I were like looking at this as a human, how did I go about solving this? Well, I started from like this kind of stage here, and I just like went as horizontally as I possibly could. Then I went as like as vertically as I possibly could. And then from each one of these kind of places, I then kind of went from 1 and then like looked up vertically. Right, I can go up, but vertically, horizontally, I can't go in this direction, but I can go more down vertically. So what's funny is that I first this is basically like an algorithm, like a graph algorithm. What I described here by going all the way to the right was depth first search, but then I started describing breadth first search. So what I'll do is I'll start over here at this starting point, and then I'll come here and look at its neighbors. So any one vertically, right? But at this point, like you want to make sure that you're considering all, like there's 4 sides to consider, right? Like up, down, left, right, because that's vertical and horizontal. So you want to consider up, left, there's something to consider, right, and down. Okay, so then we come here, and both of these again, up, down, left, right, and keep on going until we reach so at this point here we look all cases. We can only go left, but we've already come from there, so we won't consider that again. But we can't go any further here, we can't go any further to the right over here, we can't go any further to the right here, we can't go more to the bottom here. So that's it for here, right? And then we continue on traversing these elements, and then we reach another one here, and we count that it's like another output. So we increase the output by another, so there's one island here, So number of islands was 1, and then number of islands over here was incremented to 2. So that's how I would do it as a human. And again, I started thinking about the code, yeah, like a breadth first search algorithm. I kind of described the depth first search and then breadth first search. I think either one should work, but let's do a breadth first search. So this is like the first. I don't know if this is brute force or not, but let's do a breadth first search algorithm, like how I described, and time complexity and space complexity. So, I think time complexity is going to be m by n, right? N being the number of kind of, like, we're going through like all the elements in this grid. And space complexity as well, like I think we're gonna have to have like a queue or something and neighbors. I think at one point you can only really have 4 neighbors, but that list can keep on incrementing. So I think I'll also do m by n here. Worst case, though I think realistically that's a bit too extreme. Yeah, I'll confirm that. All right, so what are the different steps for breadth first search? So going a bit more into the algorithm side of things. You want to make sure you have like a visit queue, what nodes, what elements or nodes or whatever have you visited. You want to have a queue to be to visit, like a visited queue to like a to be visited. What elements do you still need to visit? This is ideally like a queue structure. Yeah, you want like a I think this would be like a set, I think, because you don't want the same node to be visited twice or to get counted for twice. You'd want like obviously a number of islands counter. Yeah, what else is in there in breadth first search? I think, you start here, you account for these 2, add them to the queue, add this one to the visit. You have to pop from the queue from the front. Yeah, I think that should be good. So let's start coding. Try that out. First thing first, I know I want result. Return result. Right, result being the number of islands. I want a visit set. Do I need a queue over here, or sorry about that, by the way. That was my handy dandy alarm. I'm forgetting how I instantiate the queue. Collections dot something queue. How do you can I just assume that a list will do the trick? But technically speaking, it won't. If I remove from the left, I forget this is the exact syntax for it. But collections.queue or something. If not, then just like set it to empty. And then when do we want to run the P? Like, what are the conditions to run the breadth first search? you want to well, okay, let me I know I'm gonna have to like write like some kind of a breadth first search like helper method. I'll define it up here. But what do we pass in? We'd want to pass in the breadth first search. We want to know which row and column we're on. So row and column. Over here as well, we want to know what row and column we're on. Row is equal to 0, column is equal to 0. I'm assuming we're starting from the top left. I think that's another question. Alright, I guess it doesn't really matter actually. Yeah, okay, well, I'll start from there. Row that, column that. For row in range length of grid, for a column in range length of grid row. So I guess we don't need this. Well, actually, visit dot add. You want to add the element at row and column, and then you want to run row and column maybe. You also want to like increment result by plus equals 1. And then in the breadth first search algorithm, I know there's a sense of direction. So directions, I don't know, we can go up, okay, we can go down, we can go left, oh sorry, that's right, left, and then this is up and down, like the x-axis, the y-axis, you know. And then for dr, dc, directions, our updated row, updated column, okay, and that would be row plus dr, column plus dc. If updated row in range of rows, so hold on, rows length of, do I have to pass in the grid as well? Don't know. Length of grid, column, length of grid, I don't know if that'll work or not. I think I might have to pass it in. All right, well, I'm kind of out of time, so I'll leave it at there. Good attempt, good first attempt. I love the way I kind of went about creating examples and everything. Kind of thought a few, there wasn't really much edge cases, to be honest. It would have been nice to think more like edge cases, test cases. Yeah, I'll leave it at that. Thank you.